Hello everyone. So let's take a look at a solved example now. Let's say your data points are 3, 13, 11, 11, 5, 4, 2. So your first step will be to calculate the average. To calculate the mean or the average of these data points. You can pause the video and calculate the average for yourself. If you calculate the sum divided by total number of data points, if you calculate this comes out to be 7. So that is the mean. Then you will create a table. Okay. So you have the x values. And if you remember the formula, we have xi minus x bar. So here you have the xi values, all the x values which are present over here. Okay. So this is, let's say, your array x or data x. Okay. This is the mean of x. And then you calculate xi minus x bar. Okay. Now you also need to calculate the sample standard deviation. And for sample standard deviation, you will need to calculate xi minus x bar square. And in the formula of sample skewness, you have xi minus x bar cube. So you need to calculate all of this. Okay. So first data point is 3. 3 minus 7 is minus 4. Square is 16. Cube is minus 64. And simply fill the table accordingly. Okay. So we have calculated all the values. Now we have to calculate the summation. Okay. So if you calculate the summation, we'll need the summation for xi minus x. So the summation of this we have already calculated when finding the mean. We won't require this, but it is 49 anyways. Xi minus x bar, the difference of each data point from the mean, it will add up to 0, right? Because some data points will be greater than the mean, some data points will be less than the mean. In fact, we have found the mean or we have found the average by taking the sum of all data points and dividing by total number of data points. So if you calculate xi minus x bar, the difference or uh, distance of each data point from the average, that will come out to be 0. This will be important in the upcoming videos when we'll discuss about central moments. Okay, so now xi minus x bar square, we'll calculate the sum of this column. If you calculate the sum, this comes out to be 122. And the last column, if you actually calculate the sum, this comes out to be 120. Okay, so now first we'll need the value of S, that is the sample standard deviation. Okay, so S will be equal to square root of a summation xi minus x bar square, okay, divided by n minus 1. N minus 1 because this is a sample. Okay. So this is square root of 122, which we have calculated already. 122 divided by 7 minus 1, that is 6. Okay. So this will be equal to, if you actually calculate, it will come out to be something like 4.5092. Okay. And now finally, we are in a position to calculate the sample skewness, which is sometimes also indicated by G1. And this is n upon n minus 1 into n minus 2 summation I goes from 1 to n xi minus x bar cube A divided by S cube, or you can take everything inside anyways. Okay. So now this quantity we have already calculated, S cube we can take outside the summation. Okay. Now n upon n minus 1 into n minus 2. So this is 7 upon 6 into 5 and 1 upon S cube. So this is 1 upon 4.5092 cube multiplied by this value we already have with us, xi minus x bar cube. The summation value we have, that is 120. So let's calculate this. Here we have 4. So 7 into 4 divided by this. So 28 divided by this comes out to be 91.68. This is equal to, this comes out to be 0.305. Okay, which is, you can say, 0.3. That is the sample skewness. In the next video, we'll take a look at the interpretation of this value.